Okay, so that's that. So first time through, just set these guys up. Your vertical asymptote is coming from where? Denominator. So in the denominator, whatever this is set equal to 0. So therefore, when you get to this part, set this equal to 0. Now, generally, we don't see a fraction like that. So since it is a 0, multiply everything by 2. If you left it like that, right, if you left it as a fraction, it still should have worked. It's so somewhere around here, then you probably messed up a little bit here. All right, let's follow this through, and then we'll take a look at what happened to your fraction. Okay? Okay, so we got this. This is in our denominator so far. We're a horizontal. Where does a horizontal come from? The ratio, because this one gave us not a 0, so it gave us a ratio, so it came from the exponent in the numerator is the same as the exponent in the denominator. So right away, you're like something like this. So right away, you look like this. Over something with an x here, right? Something with an x. A point of discontinuity, where does that come from? It's factored out, so it's coming from the top and the bottom. So I would write this again, equal to 0, so that I can pull out my factor. This is the point that gets factored out. So far I'm like this. This part right here is the part I don't know. So I take this guy right here and I say plus n. Something's got to change to that guy. It's the only thing that's left by itself. So I don't want to mess anything else up. So now you have this situation, because this point has to come out somewhere. We know that the negative 1 will work, but it's that 2/3 that we got to get there. And we got this to work with. So plug in the point that you know. You know that's 2/3 and the negative 1. That's a point that you have. So plug in the x is negative 1 and the y is 2/3. Somewhere here, there's the point of discontinuity. Plug in the x and the y, and it should work. Now you guys that left this as x minus 1/2, this didn't work. So let's see. Oh, okay, Woody, she's still there. All right, so we're going to take out your x plus 1 and just set this equal to 2/3. So this is a negative 1, and this is a negative 1. So did you get negative 3/2 down here? Over negative 1 plus n. And then what did you do? You multiplied both sides by negative 3/2. Okay, so put this over 1 and multiply both sides by negative 3/2. And that should take that out and make this a negative 1. We got a negative 1. Something's off. Something that I'm staring at and something's off. It should work. Because if you set this equal to 0, it's still a half. All right, let me think about that one. Let me think about why that's not working. Yeah, it came out to be 0. Well, you can't give it an x or a y, so just give it an n.
Yeah, but how do you know it's a plus?
Well, you don't know, but if you say x plus n, did this come out to be a negative? So then you're just going to put it in as a -1. It'll work itself out when you find the sign. But for now, it's something is added to that x. Because when we get to here, this was what we're known so far, but we still didn't account for this part. So that's the part that's going to change something. So that's the plus n. So if you just kind of stick a plus n there, that's fine. It works. All right, so we'll get to the bottom of why that one's not working. All right, we'll figure that one out. All right, any other questions on this guy? Point of discontinuity, don't forget it's not as easy as just building that. You have to account for this guy. Like the colors. All right, and we'll put here's another point of discontinuity. Vertical asymptote, where did that come from? Denominator. It's a value in my denominator that I can't use. All right, a value in my denominator that I can't use. Again, horizontal is a ratio. Somewhere I have to make this ratio work. So somewhere I start with 2x over x. And my point of discontinuity, there's my factor, x plus 2, x plus 2. And I need to get this 0 in here. So again, I need to put this plus n over here. And plug in your point of discontinuity. Here's your point. It's an xy value. Plug it in. And reduce it first and plug it in. And then you'll get your n. Bring it back. And actually, you could leave it like this. I factored out the 2 because everything else was factored. But you could leave it like this. This doesn't bother me. I just factored it out so everybody had all factors. The one thing that I always say, make sure you say y equals f of x equals h of x equals, give it an equation. I see all the time everybody goes all the way through this and then forgets to give me the equation. So make sure you give me an equal sign. Good? Questions? I know these are tough. What always throws everybody off is that other piece of the point of discontinuity. That's where the plus n comes from. And if you write yourself a little at a time where you're supposed to be, it kind of helps. I know what if I'm given this, put this in first. That's that. If I need this, I've got a negative 2x over a 1x. Build it as you go. You've got a point of discontinuity. You got an x plus 2 over an x plus 2. Even keep those together so that you know that's your point of discontinuity. For this part right here, there's my x plus n. So the only guy I'm going to hook it to is this one right there. It's going to have to change something. So build it one step at a time. And again, plug it in. Put it in your y equals and see if all that happens. You can put your horizontal asymptote in there. And your y2. You can look for your point of discontinuity in your table. You'll find the pieces. This one was a little different. Okay, horizontal asymptote, where does that come from? Denominator. So right away, I know these factors go in my denominator. Okay, vertical asymptote. Sorry. Horizontal asymptote, where did that come from? A ratio. Again, we have a ratio. That means the value of x in the numerator is the same as the value of x in the denominator. So far I have an x squared. I need to make it a 2 over 1. So I start like this. I get a y-intercept. That means somewhere crosses my y-axis at negative 2/3. What's the value of x? There's your point. Remember when I showed you the zeros? We had the zeros, the x zeros, and they were in the numerator? I said sometimes it's a factor, sometimes it's an actual point.
I didn't know it's squared.
because if this tells me I need to be 2 over 1, so that tells me the degree in my numerator has to be the degree in my denominator. So right now, if I FOIL this guy out, I have an x squared. So those have to be exactly the same. This is how we're going to start. And because it's 2 over 1, I stick a 2 up there. So now I get a point. And my point that I can check here is my 0, negative 2/3. So something is making this change. So I just leave it like that, plus n. And now I can plug in my x of 0. I can plug in equal to my y of negative 2/3. And I can solve for n. Then don't forget to bring the whole thing back. Okay? You remember the on Fridays it said zeros? It said I don't remember, like x equals 3, and I said sometimes it's going to give, or it's going to give you, you need to know that was in your numerator, and sometimes you need to know this was your point. So it's kind of the same thing with the y-intercept. Where else would I put that? I really don't know what else, why they would give that to me. So if you visualize it crossing your y-axis, that's the point where x is 0. That's the point that's going to help you out. Okay. And again, I'm fine with this. If you didn't factor out the 2, I'm fine with that. Generally, we leave it in all factors, but I'm fine with this. I would just say leave it like that. That's fine. It's not buying you anything to factor it. Again, plug it in your calculator when you're done. Make sure that those are there. Questions? And I think there was one more, right? Yeah. Another y-intercept. Where do we start your vertical? This is your denominator. This guy had a slant. So somewhere here, we're dividing by 1. This 1 up here doesn't really matter to you right now. This matters in your denominator, but when you work all this out, you will see it back in your denominator. Your slant and your y-intercept, here's a point. In case you need your point to plug in. So your y-intercept said, I synthetically divided, and I ended up with this. This was my coefficient of 1, and I had a remainder. So at this point, once you build this, then you need something to plug it in to find r. So look for a point, and that's your y-intercept. So plug in your 0 and your 1, your negative 1. Find r, and then bring it back to this. When you bring it back to this, don't forget, these are rational functions. So we get one term. Find the common denominator and put it over one term. Well, because remember when you synthetically divide something and you get 1, 1, and say this says 2. So if this is 1x plus 1, remember this is your remainder. And so what did you do with the remainder? You took this and you put it over the denominator. So we don't know what this is this time. We do know your denominator because it's in your denominator. So this is the guy we want to find. By finding this, it helps us figure out what else was up here. Like I can probably work backwards and get up to here, but I can't do this part. I'm stuck. So work yourself backwards. Find this. This will generally fall right into place. Just make sure that you keep track of what's in your denominator because that has to go under there. Solve for r and bring it back. And don't leave me 2 terms there. Give me 1 term. Somewhere I'm missing an x, right? We should say x. Or no, that's right. That's what it is. And we're good. Questions? Yes. So for this one, we said we have to have one term because this is irrational. So I hook this together, I put this over 1, and my common denominator would be x minus 1. So this guy is the same as doing this, x minus 1 times x minus 1. This guy needs an x minus 1. So I'm going to multiply it by x minus 1. This guy has an x minus 1, so I'm just going to do this. Then these are your perfect squares. Just FOIL this all out. These are your perfect squares. Collect your like terms and resolve your equation. Don't forget it needs to be over one term. Questions? These are probably the most confusing because you're not given a lot to work with, but you got to work backwards. Yes?
When you have, what are you doing with the red writing?
The red writing?
And how do you get, why do you divide by 1?
I don't know what I did there. Oh, what I did here was I just took this minus 1 and made it a minus r. This is a minus 1 under here, so it's this. So basically, I just wanted to show you I was just replacing this with a minus. Because it's over 1. Anything over 1 is itself. So I probably put the fraction so that you would see anything over 1 rather than see me just remove the fraction. Because normally we can't remove the fraction. But in this case, it's a 1, so I can. And this plus becomes a minus. Probably just my way of trying to show you that anything over 1 is itself and just change the sign. However way you want to solve that is fine with me. Subtract 1 first, and then negative r over 1. Whatever you want to do is fine with me. You don't have to do it this way. You can do it this way. So if you did this, you would subtract 1, cross multiply, and r is equal to 2. That's fine too. Good? Any questions at all? I'm finding these. Working backwards probably has a little bit